Thus far, we have looked at an intuition for models, understood what we mean when we say we are building a model based on data, and then we looked at a couple of examples of models, and then we looked at when we can say that whatever the model is suggesting is statistically significant. Okay, so these are all important ideas that we have looked at so far. Now we are going to look at one more extremely important idea when it comes to data analysis, which is the model, what the model is saying, is it a trend or does it have causal implications? Okay, so we really want to point out that so far the models we have looked at, they only show that the variables we are looking at are related to each other. They show relationships. So for example, this model is telling us that there is a relationship between the length of time somebody smokes and whether they have lung cancer or not. And we also saw that this model is actually statistically significant because the bands don't overlap. So clearly, even if you repeated the experiment many times with many different samples, you're still going to see that people who have lung cancer have smoked for a longer number of years than people who don't have lung cancer. So we are quite confident that this finding, what the model is telling, is quite true. Similarly, we saw a different model where we said ankle sizes of people are related to wrist sizes, and that people with larger ankle sizes will tend to have larger wrist sizes as well. Okay, once again, we see that this model is statistically significant because a horizontal line will not fit into this band. Okay, so clearly, even if we repeated the experiment many times, we're going to see this relationship. That's what the model is telling us. So here we are seeing that both of these models are statistically significant, but we have to be very careful and point out that these models only show us that the variables in concern, that variables of interest, are related to each other. Okay, now we could make two different types of statements about these models. We could say larger ankle sizes are related to wrist sizes, or we could get much stronger and say that larger ankle sizes cause people to have larger wrist sizes. Okay, in one case we are saying A and B are related. In the other case we are saying A is what caused B. Okay, very different sort of statements. Similarly, we can say that people who have lung cancer on average have smoked for a longer duration, that there is a relationship, versus smoking actually caused the lung cancer. Okay, now of course we know based on lots and lots of studies that smoking in fact causes lung cancer. That is established almost beyond doubt. However, we cannot infer that just based on our model. Our model is not establishing for us that smoking causes lung cancer. In other words, the kinds of models we are looking at don't allow us to establish causality, to say A caused B, and therefore, if I want to have an effect on B, then I can go and change A and then get the corresponding effect on B. Okay, now this may very well be true in the case of lung cancer, but our model doesn't warrant that conclusion. Okay, so we are only looking at models here that show relationships. We cannot infer causality. Okay, so these are statements that just show the relationship between models, whereas these are statements that are much stronger, or sometimes we call them as much more opinionated statements to say that something causes something. Okay, this is very important to understand because people often make the mistake of looking at a model and then sort of assuming that the model is giving us causal statements. That's not the case. Okay, so in order to establish causality and to make opinionated statements, we need different techniques that we will look at later in the course. The techniques we have looked at so far don't allow us to make these sorts of opinionated statements. Okay, so this is a very important concept to understand and keep in mind.